Okay, let's jump right into this explainer and fundamentally rethink pretty much everything we thought we knew about our body's defense system. For the longest time, we've been handed this very specific, honestly pretty aggressive narrative about how our bodies keep us healthy, right? We're always talking about fighting off bugs, battling colds, or boosting our defenses. But today, we're going to look at the actual biological reality. And let me tell you, it is way more elegant and way more complex than just some simple, chaotic war zone happening inside your veins.
If you're like most people, you probably picture your immune system as this tiny, aggressive, internal military force just violently fighting off bad guys all day. When someone says the word immunity, you likely picture microscopic soldiers, completely armed to the teeth, patrolling your bloodstream and blowing up invading pathogens. But what if I told you that eliminating microbes is actually only a fraction of what your immune system does? It's seriously time we upgrade our understanding from this old battlefield analogy to what it really is, a highly sophisticated, hyper-intelligent management system.
So let's start with Section 1, the invisible defense guarding our daily lives.
Think about this for a second, because it's kind of wild. We do not live in a sterile world, at all. We are literally covered in microbes. We breathe them deep into our respiratory tract with every single breath. We swallow them with every meal we eat. Your skin, your mucous membranes, they're in constant 24/7 contact with the outside environment. I mean, your gut alone hosts this massive, sprawling ecosystem of bacteria. And yet, despite being bombarded like this constantly, we spend the vast majority of our time perfectly healthy. It's so easy to just take that for granted, but behind that daily normalcy is a relentlessly precise biological system working entirely behind the scenes.
Here is the absolute crucial takeaway. Modern immunology doesn't define immunity as just some infection-fighting army. It's actually a complex life regulation system. Its real job is to manage your environment and maintain homeostasis, which is just a fancy word for balance. The word itself actually comes from the Latin immunitas, which originally meant being exempt from a duty or a burden. In medicine, sure, it came to mean protection from disease. But today, we know immune cells do so much more than that. They act like a cleanup crew for dead cells, they detect damaged tissue, they help repair our organs, and they carefully manage our relationship with all those good bacteria in our gut. It's a master system designed to limit collateral damage to your own tissues while keeping your whole body in total biological harmony.
Which brings us to Section 2, recognition before attack.
This represents a massive paradigm shift in how we understand our cellular defenses. We actually have to completely toss out the old self versus non-self idea. We used to think the immune system's only job was super simple: figure out what is you and ignore it, and figure out what is not you and kill it. But actually, no. The immune system is way more like an intelligence network. It relies on recognizing an anomaly, sure, but then combining that with a specific context to make a highly calculated decision. It looks at what it found, exactly where it found it, whether the surrounding tissue is damaged, and what other chemical signals are floating nearby. So the formula isn't just attack the foreigner. Its recognition plus context leads to a decision.
To really grasp why this context is literally life or death, just think about these daily examples. If your body just blindly attacked everything foreign, we wouldn't even be able to safely digest food proteins. We couldn't host the healthy gut bacteria we absolutely need to survive. In those cases, the immune system encounters foreign things, reads the context, and decides to just peacefully coexist. On the flip side, if it strictly ignored all of our own cells, if self was always a free pass, it wouldn't be able to attack our own tissues if they became dangerously altered, like a cancer cell, or if they were hijacked by a virus. The system has to be incredibly smart. It has to know when self becomes dangerous and when non-self is perfectly fine.
So, how does it do this? That's Section 3. 2 defense strategies.
To handle these insanely complex, split-second decisions, vertebrates like us have evolved 2 distinct but deeply connected biological strategies. First, we have the innate system. Think of this as your immediate, early responder defense. It uses physical barriers like your skin and these really fast-acting cells like macrophages. They are good to go the absolute second a threat appears. Then we have the adaptive system. Now, this one takes a little longer to spin up, but it uses highly precise B and T cells that target very specific threats. And the absolute superpower of the adaptive system? Memory. Some of these cells actually stick around long after the fight is over, so if you ever encounter the exact same threat again, your body neutralizes it instantly before you even feel sick. By the way, that is exactly how vaccines work.
But here's the thing you really need to know. These aren't 2 completely separate armies fighting their own isolated wars. Not at all.
It is one continuous communication relay. It's like a relay race where the innate system finds the danger, raises the initial alarm, and then essentially points the adaptive system in the exact right direction. Then the adaptive system steps in, finishes the job with absolute sniper-like precision, and leaves behind a memory of the whole event. It really is just one beautifully unified defense mechanism.
Okay, moving right along to Section 4, fighting well and stopping well.
This part is perhaps the most counterintuitive, but also the most fascinating secret in all of immunology. We always focus on the fight, but what happens when the fight is over? Knowing how to stop an immune response, which biologists call contraction, is just as vital as starting one. Think about it. During an infection, your body ramps up inflammation, right? It multiplies immune cells to clear out the pathogen. But continuing to fight after the pathogen is already gone? That can cause severe, sometimes irreversible damage to your own tissues. The system absolutely must shrink the number of active cells, dial down the inflammation, clean up the microscopic debris, and return the tissue to a state of homeostasis. If it fails to hit the brakes, you get devastating conditions. Things like allergies, where the body overreacts to harmless things like pollen, or autoimmune diseases, where it literally fails to tolerate its own tissues.
And honestly, this concept completely debunks a massive popular myth. You see it on grocery store products all the time, right? Pills and juices promising to give you maximum immunity. But scientifically speaking, you do not want maximum immunity. An immune system dialed up to the absolute maximum would literally destroy your own organs. What we truly want, and what your biology is constantly striving for, is appropriate immunity. There's a quote that perfectly captures the essence of modern immunology. A healthy immune system is not the strongest one, but an appropriate one that responds exactly as much as needed to the right target. A healthy system responds exactly when needed, where needed, to the exact extent needed, and crucially, it knows exactly when to pack it up and hit the brakes once the job is done. It is a masterpiece of moderation, not brute strength.
Finally, let's wrap this all up with Section 5, the 6 key verbs of immunity.
So, how do we package all this complex biology, the macrophages, the T cells, the homeostasis, into an easy, memorable mental model you can actually take with you? Instead of trying to memorize a textbook full of countless cells and molecules, just remember this beautiful life cycle represented by 6 simple verbs. 1. Your body must recognize the change or the threat. 2. It must decide what that means based on the surrounding context. 3. It has to respond using those innate and adaptive tools we talked about. 4. It must regulate the intensity of that response so things don't go totally overboard. 5. Once the threat is neutralized, it must resolve the inflammation and heal the tissue back to normal. And finally, 6. It will remember the encounter so it is perfectly prepared for next time. Literally every single cell and molecule in immunology fits perfectly into one of those 6 steps.
As we close out this explainer, I want to leave you with a fundamental challenge to the way we treat our health on a daily basis. If your immune system is actually this masterful manager of balance, this incredibly careful judge of context, how can we better support its delicate decisions rather than just blindly trying to boost it with random supplements? I'm going to leave you with that provocative thought to reflect on your own body's brilliant internal balance. Until our next explainer, thanks so much for joining me.